All right, hi class. Here, let me go ahead and do this so you can see me. Good to see you all. Hopefully this will be our last online lesson for this week, and then we'll see each other in person next week. I haven't activated the account that I was using before so you could see me while I was teaching the lesson. So I'm gonna go ahead and switch back to our notes for today. And you have access to these notes on Google Classroom. So if you don't have a printer, if you haven't printed these off, that's fine. You're just gonna have to write these notes down. Anything that is typed out here, you need to write down, okay? So this first portion here, so this lesson, we're gonna be looking at lesson 4.2. We're gonna generate equivalent expressions. So you're going to watch a video and take notes from that video. So like a video within inside this video. So you're going to need to fill in, well, you're only just filling in these two parts. Commute means to what, associative means to what. So I'm going to post a link to the video for you to watch about the Cococommodians. All right, now that you've watched that, I'm not gonna fill this in here because I want to see if you watched that video. All right, the second part, what you had to do was look at the distributive property. That wasn't in the video. But I'm going to talk about the distributive property here. So let's say you go to McDonald's and let's say a combo meal. So combo meal number, like a combo meal, let's say comes with 2 cheeseburgers and 1 Coke. So if you order 2 cheeseburgers and 1 Coke, you get 2 cheeseburgers and 1 Coke. But let's say you are at McDonald's with your 3 friends and they're like, you ask them what they want to order and they say, I'll just take what you want or what you're gonna order. So you will order 3 combo meals. So how many cheeseburgers will you get? Well, you will get 6 cheeseburgers. I wonder if I could do this. Copy. Paste. That's really working hard to do that. I don't know if I should have done that. You know what? This is what I'll do. Oh, I'm really regretting I did that now. All right. Well, we know that we would get 6 cheeseburgers and you would get 3 Cokes. Oh, man. Technology. All right. So you would get 6, we'll just call this cheeseburgers. And you would get 2 Cokes, right? Oh, it's another C as well. We'll say that 2 drinks, right? So we can see that up here, 3 times 2C plus 1T, not T, D, is the same as we are distributing this in. 3 times 2 gives us 6C plus 3 times 1 gives us 3D. So this actually isn't 2D, it would be 3, right? Because you have ordered 3 Cokes. Okay, you're just distributing that in. All right, so let's go ahead and look at this example here. We are going to use properties of operations to write equivalent expressions. The Student Council has spent $300 on the supplies needed to sponsor a dance concert fundraiser. 3 council members wrote the following expressions to represent the total amount raised for tea tickets sold. Can they all be correct? So it's 3 different expressions. 3 different people wrote these expressions. Are they the same? We're wondering if they're the same. Well, this one here, let's see if that's what we're wondering, if these are all the same. So I'm going to rewrite this one over here. We would have 6t minus 50. What we'll do is distribute. If we have the parentheses, we distribute that in. So we would have 6t minus 6 times 50. 6 times 50. which is 6t minus 300. So these are the same, right? That's the same thing. What about the last one? Negative 300 plus 6t is the same as 6t minus 300. We can do that because of the commutative property of addition. We are reorganizing this, so we are moving it to the other side. This isn't, I mean, this is negative, but that's the same. Maybe think about it this way. Plus negative 300, right? It's plus a negative. That is commutative property of addition. Well, plus a negative is just 6t minus 300. So are they all the same? Yes. All right, let's go ahead and look at like terms and unlike terms. So these are all like terms. Like terms have to have the same variable and same exponent. So like terms have the same variable and they have to have the same exponent. All right, so unlike terms, we'll write some examples of unlike terms. An unlike term, the variables are different. So that could be like 2y plus 19x. Those are unlike terms. Another set of unlike terms, the exponents are different. So if we had 4w squared minus 10w, those are unlike terms. The variables are different. We could have 14.2s minus 12r. Those are unlike terms. The exponents are different. We could have 32a cubed plus 9a squared. These are unlike terms. These are our terms here. Remember, a term is a number, a variable, or the product of the two. And another example, one term is a constant and the other one is a variable. So 8y plus 5, these are unlike terms. We have 8y as a term and 5 as a term, but they are unlike terms. So they don't have the same variable and they don't have the same exponent, one or the other. And we're gonna be doing a lot of practice of these next week, okay? So this might be new for some of you. So write an expression by combining like terms. Combining means we can move those together. Well, let's reorganize this. We would have 3x minus 5x plus 2y. We can combine our like terms. So what is 3 minus 5? 3 minus 5 is negative 2. So combining these terms, we would have negative 2x. The variable is still there. Plus 2y. That y is still there. So this is our equivalent expression, negative 2x plus 2y. Let's go ahead and combine these like terms. 1 over 3x plus 1 over 6x plus y. A good strategy is to highlight our like terms. These two terms are like terms, so we can combine those. 1/3 plus 1/6, well, that is the same as 2/6x plus 1/6x plus y, which gives us 3 over 6x plus y. So we have 1/2 x plus y. This expression here is equivalent to this expression. Okay? Which of the expressions below are equivalent to negative 2/3 x minus 2? So we're wanting to see which ones are equivalent. Well, let's look at the first one. Plus a minus is just the same as minus. So we can rewrite this as minus 2 over 3x minus 2. They're the same. Okay, I'll check that off. What about the second one here? Is the second one equivalent? Well, let's rewrite it. Negative 2 over 3x. Is this a positive or negative 2? It is a positive 2. They are not equivalent because here we had a negative 2, so it is not equivalent. And this last one, let's look at it. Let's combine our like terms. Negative x plus 1/3 x. Negative x plus 1/3 x minus 2. Well, negative x is the same as negative 3 over 3x plus 1/3 x minus 2. 3 over 3, or negative 3 over 3 plus 1 over 3 is the same as negative 2 over 3x minus 2. So these are equivalent. So this one is also correct. So it is the first one and the second one. All right, Nancy wrote the expressions 3x minus 12 to represent the relationship in the table of values. Use properties of operations to write two equivalent expressions. So we just want to rewrite this. So what she had was 3x minus 12. We could rewrite this as negative 12 plus 3x. And we could also rewrite this as, well, let's use the distributive property, 3 times x minus 4. These two expressions here are equivalent to this one up here. Number 2, use the properties of operations to write two expressions that are equivalent to 3 over 4n plus 8 plus 1/3 z. So we'll rewrite this. Well, we could just have 3 over 4n plus 8 plus 1 over 3z. That is equivalent. We're just changing the association, the grouping. And another one, we could rewrite the order, 1 over 3z plus 3 over 4n plus 8. These two are equivalent. We have just changed the order because commutative means to commute, which means to move. Okay? Please write down any questions that you may have. Next week, we are going to spend lots of time practicing this, so don't feel too overwhelmed. Right this week, I was just front loading a lot of information, and then next week, we're going to practice in class. All right? Keep up the great work. Let me know if you have questions. Bye.